Hey, so we've got this problem, and the whole point of this lesson is for us to learn how to decompose functions into different functions. Alrighty, so we have f of x is equal to 5 over 3 minus square root of 4 plus x squared. All right. So when we're trying to decompose this function, it wants us to write f of x as two functions, h of g of x. All right. So this is not a unique thing. Like you can decompose a function into a bunch of different ways. Um, for these types of problems, my best suggestion is to try and think of functions that we've dealt with before and try not to overthink it too much. Um, Like example for this one, there's a bunch of different ways you can decompose this, but if you decompose it, let me show you. So I could write this as if my g of x was x squared, my h of x would be 5 over 3 minus the square root of 4 minus x, right? Because if I plug in g into my h of x, I will get this f of x. If I plug in x squared everywhere I see an x, I'll have squared and squared, which is exactly what my answer should be. Now I plug this in. Granted, I have the teacher preview, so I could see the answer, but a couple of different ones you could do. Like you could do 4 plus x squared here and do an x here. Then everywhere you see an x in your h of x, you would plug in 4 plus x squared. And whenever you plug it in, you get your f of x. The answer that they're looking for in this problem is g of x is equal to your denominator, 3 minus the square root of 4 plus x squared. And then h of x is equal to 5 over x. This is the answer that they're wanting for this problem. But I'm not going to lie, there's a bunch of different ways you could get this answer. So if you get an answer and it doesn't work, maybe try a different two functions and see if that works. That's my best suggestion for this. It may not be necessarily that you're wrong, but it may be that they wanted you to get a different one. And so what I meant at the beginning by trying not overthink it is we've dealt with functions that look like 1 over x. We've dealt with functions that look like square root of stuff. So I'm assuming that that's kind of how they want you to think about this.